Okay, please open in your learning workbooks to page 134. We're going to continue our discussion of section 2.8 by solving some example problems that you might see in ALEX. Okay, here we go. Suppose we have the following functions. G of x is equal to x plus 8. And h of x is equal to the binomial x plus 3 times the binomial x plus 4. Find g over h of 3. Okay, let's solve this. G over h of 3 means to take our two functions, g and h, and divide them, where each one is being evaluated for the input 3. Let's figure out what both of these things are equal to in our side workspace. We know that g of x is equal to x plus 8. Therefore, g of any input would equal that input plus 8. In this case, the input x is 3. So replace every x with a 3 in parentheses, then simplify. Okay, these parentheses are unnecessary because there is no subtraction sign in front of them, there's no multiplying number, and there's no exponent, so we can drop them. So this gives me 3 plus 8, or 11. Okay, h of x is equal to x plus 3, x plus 4. So if we want to find out what h of 3 is, we just have to replace every x with a 3. When we replace something with something new, we put the new thing in parentheses. Okay, these parentheses here and here are unnecessary. So we just get a 3 plus 3 times a 3 plus 4. Order of operations says to work in the parentheses first. 3 plus 3 is 6. 3 plus 4 is 7. And then finally we multiply and get 42. So g of 3 equals 11, and h of 3 equals 42. Putting both of those in the original problem, we have 11 over 42. 11 is a prime number, therefore this fraction cannot be reduced, and this is our final answer. Let's try another one. Suppose f of x equals x subtract 5, and g of x equals 3x subtract 3. Find f plus g of negative 1. Okay, to solve this problem, we have to take our two functions, f and g, and add them together, where each one is being evaluated for the input negative 1. Let's figure out what each of these things is separately in our side workspace, and then add them together. We know that f of x is equal to x subtract 5. Therefore, f of negative 1 would be negative 1 subtract 5. Notice that I'm not using the parentheses here like I did in the previous problem because the x does not have a multiplier It's not being subtracted, and it doesn't have an exponent. So I get -6. Okay, let's do the same thing for g of x. G of x equals 3x subtract 3. To find g of -1, replace each x with a -1, using parentheses where necessary. Well, this x has a multiplier, therefore parentheses are necessary. 3 times -1 is -3. -3 subtract 3 is -6. So we got -6 for both pieces of our answer. Putting those back in our original problem, we get -6 plus -6. Negative plus negative makes even more negative. The answer is -12.